So I'll say to start the Gemba walk. So Gemba walk means go where the action takes place. And here we have a lot of action, meaning creating prototypes. And they have a lot of technologies. Can you briefly explain, before we start, what technologies are we going to see in this virtual walk?
Yeah, we see manufacturing stations, different manufacturing stations that will later on be orchestrated together to the Lighthouse project. This facility here is just a provisional facility. We will move next year into a very new modern building. We have 1,000 square meters to show this factory.
I can't wait to see it.
Yeah, same here. In the meanwhile, we do here some first developments and tests. And we will see robots, we will see augmented reality, artificial intelligence, tracking technology. It's a snapshot of what we have currently here.
So let's go.
Let's go, okay.
Let's go. So let me plug my computer and I follow Dr. Gorecky. So where do we start?
We start here with the product itself that we're going to do. We have a factory, we have a demo factory. In this demo factory, we need products. So we have a demo product, which is a drone that is partially produced here. So we are some sort of the OEM for this drone. In order to comply with the new customer needs in Industry 4.0, you can configure it. So there are 3 different variants: small, medium, and large. There's the quadrocopter and there's a hexacopter. And yeah, it contains of the faceplate, of the arms, of some electronic parts, and the propellers. This is going to be produced partly and then assembled here and tested here on different stations. The stations, they are interconnected by using mobile robots. So we have here one of our mobile robots. In the end, we will have 2 different types of mobile robots. Important is all our products, they come with an RFID tag. On this RFID tag, we store not only the history of the product, but also the future of the product. So the production actually starts with the initialization of the RFID tag. So we describe what a product should look like one day. And then this RFID tag is moving through the production from station to station to make sure the product is built the right way. Now, we might start with the production of the base plate. Therefore, yeah, let's just follow me. Say this might be a very raw form of this drone that we're going to use. And we have here base plates. We have here this setup with the CO2 large-scale laser from the company Project. And this laser can cut different materials, wood and also plastics. So we will laser the base plate as we need it for the different configurations. And the robots here, collaborative funnel, CR35 is the largest collaborative robot on the market. And it will put automatically the materials on the laser, and it will take out the materials once they're finished and give them to the mobile robots to continue the process. It's very interesting, this setup, because also this laser by itself was not made to collaborate with other machines. So we have built in some additional systems, gateways, sensors, to make it smart, make it even smarter. By itself, it's a super smart machine, but it was not meant to collaborate with the robot, and we have retrofitted it to fit better into our Industry 4.0 environment. So the base plate is done. What we done here? Now we need the arms of the drone, and the arms, they are 3D printed in our facility. So Myrna, just follow me.
Let's go. Let's go.
It's
3D printing farm.
3D printing farm. It is work in progress. We have here 9 or up to 9 printers in these cubes. And these are actually standard 3D printers, as you can buy them for yourself at home. We show what we can do with this technology. Again, we use standard 3D printers. By the way, there's one printing here if you want to see.
Wow. Yes.
And, we have equipped them. Also down. We have equipped them with additional technology to make them smart. So you see here gateways, master control, and sensor solutions, so that we can survey all the printing in all these different cubes. Then we can compare the data that we collected here and analyze, okay, which printer is performing better and if we have some quality deviations. The cool thing is we designed this completely modular. We have these plug connectors here, just like USB. You can remove them and take the printer and use it also in different setups. These cubes are very flexible. You can take them out, bring them into another setup. In the center part, we are currently installing a robot that later goes take all the printed parts out and gives them then again to the mobile robots, so the mobile robots can distribute parts.
So these are the arms of the.
These are the arms of the drones.
Of the drones. Perfect.
We of course control the arms. So we have I forgot to mention two things. The 3D printer setup is developed with about 8 to 10 different partners of our network. The laser cutting station, here we have about 5 partners involved with their technologies and know-how. Now we have a small quality control system where I think 2 partners are involved. We have measurements tools, caliper, that are made digital. So just with one click, and you might see it here, with one click, I transform the value here. I have chance to measure. Let's see if the measure is good or bad. Fully digitalized, no need to write anything down, no need for the operator to open an Excel table. And that's a tool and a technology platform that we test and co-develop with 2 of our partners for quality control. Let's say the quality control of the arms is all fine. Then we come to our manual assembly station, supported by a collaborative robot. Collaborative robot from Escava is handling the materials, positioning the arms and the plates, while the operator is performing other operations. We have here the manual workstation system from Unix Meccano, and we have the light system from Citago. And I just can give you an example how this works. Simple pick by light with the sensor integrated. Let's take it out, change, and it tells me what I have to do. And so I can go step by step. And we have from the first component here also the system for the screwing. It's a local company here from the region that works very much into the watchmaking industry, and they're also partnered with us in order to develop new digitalization strategies. So
Perfect.
let's just give you an example here. Again, work in progress, but that's our manual assembly station. And maybe last but not least, a little bit outlook on what we can do. This is again a manual workstation. It's more a research project. It's not directly related to the Lighthouse project, but we use here neural networks in order to track and trace different parts of a small computer that we want to assemble. And then we have here a projection solution that highlights. We have a projection solution that highlights the parts and also ones can get some instructions. how you can see. Here we have the instructions.
Wow, so it's like the workflow, automated workflow, how
It's
you...
an automated workflow system. Yeah.
Wow.
Okay, that's work in progress for a research project. What we have seen on the other stations is more like state-of-the-art technology that we can already purchase on the market. So these are technologies that you can integrate right away in your factory if you want. Developed and tested with the Swissmart factory by our network. So
impressive.
Yeah. And yeah, there are a couple of more stations currently under construction, not only here but also at our partner sites. And as I mentioned, by spring of 2021, we want to have the full assembly line ready to produce drones.
We'll do another cappuccino.
I think that will be definitely worth it.
Yes.
And there the journey starts, of course, with the customer. We have an online portal. It's currently designed. It looks like if you want to buy a Tesla, configure your drone, send the production order to us, and then we do all the things.
Perfect. Thank you so much, Dominic.